Pacific Ocean, the rare natural phenomena that appear without warning. The Pacific Ocean is not just the largest body of water on Earth. It is a living system, a restless world of blue surface, hidden currents, volcanic fire, violent storms, glowing waves, migrating giants, and rare natural events that can appear suddenly, vanish quickly, and leave even scientists searching for answers. From above, the Pacific can look calm. A sheet of endless blue stretching from the coast of Asia to the Americas, from the Arctic edge to the Southern Ocean. But beneath that calm surface, forces are always moving. Heat rises, pressure builds, winds shift, plates collide, currents bend, clouds gather. And sometimes, when the conditions align for only a brief moment, the Pacific reveals something extraordinary. A sea that glows at night, a whirlpool the size of a city, a wave that seems to come from nowhere, a red tide that paints the water like fire, a volcanic island rising from the deep, a storm system so vast it can be seen from space. These are not myths. They are rare natural phenomena of the Pacific Ocean. And they remind us that the greatest ocean on Earth is still full of surprises. The Pacific covers more than 1/3 of the planet's surface. It is wider than all the land on Earth combined. Inside it are deep trenches, mountain chains, coral kingdoms, island arcs, abyssal plains, and underwater volcanoes. Its deepest point, the Mariana Trench, descends into darkness more than 11 kilometers below sea level. Its surface connects thousands of islands and coastlines. Its winds influence global weather. Its temperature shifts can change rainfall, drought, storms, fisheries, and food supplies across continents. Because the Pacific is so enormous, every natural phenomenon here feels larger, stranger, and more powerful. A small temperature change in one region can affect weather thousands of miles away. A volcanic eruption on the seafloor can create new land. A pressure system over warm water can grow into a typhoon. And a quiet underwater earthquake can send energy racing across the ocean faster than a commercial aircraft. The Pacific is beautiful, but it is never truly still. One of the most haunting phenomena in the Pacific is the glowing sea. On certain nights, far from city lights, the ocean can shine with an electric blue glow. Every breaking wave becomes a line of light. Every splash becomes a burst of stars. Every movement in the water seems to awaken something magical beneath the surface. This glow is called bioluminescence. It is produced by tiny organisms, often plankton, that release light when disturbed. For sailors, divers, and coastal communities, a glowing ocean can feel like entering another world. But the science behind it is just as fascinating as the beauty. Bioluminescence is a survival strategy. Some organisms use light to confuse predators. Some use it to attract prey. Some use it to communicate in darkness. Some create flashes so sudden that they expose anything trying to attack them. In parts of the Pacific, especially near warm coastal waters and nutrient-rich zones, bioluminescent blooms can appear suddenly. One night, the water is dark. The next, the waves are glowing. Then, just as quickly, the phenomenon disappears. The ocean keeps the memory, but the surface returns to normal. Another rare event is the red tide. The name sounds simple, but the phenomenon can be dramatic. When certain microscopic algae multiply rapidly, They can change the color of the water. Sometimes it becomes reddish-brown, sometimes deep orange, sometimes rusty, murky, or almost black. These events are often called harmful algal blooms. Not every bloom is dangerous, but some produce toxins that affect fish, shellfish, marine mammals, seabirds, and even humans. In the Pacific, red tides can be shaped by sunlight, temperature, pollution, nutrient runoff, and ocean circulation. They can appear in bays, along coastlines, and in open water. From a distance, the sea may look stained. Up close, it is a sign that the microscopic world has entered a sudden explosion of life. But what begins as abundance can turn into danger. When algae die and decompose, oxygen levels can fall. Fish can suffocate. Shellfish can become unsafe. Marine food chains can be disrupted. The Pacific is full of beauty, but some beauty carries warning signs. Then there are rogue waves. For centuries, sailors told stories of enormous waves that rose without warning in open water. Many people once believed these stories were exaggerations. But modern measurements proved they were real. A rogue wave is not simply a large wave. It is a wave that is unexpectedly massive compared to the waves around it. It can appear suddenly, tower over a ship, and strike with terrifying force. In the Pacific, where storms, currents, winds, and long-distance swells can interact across huge distances, rogue waves are possible in some of the most remote waters on Earth. Their formation is complex. Sometimes waves from different directions combine. Sometimes currents compress wave energy. Sometimes strong winds build unstable seas. Sometimes the ocean seems to focus its power into one monstrous wall of water. A ship crossing the Pacific may be surrounded by rough but manageable waves. Then one wave rises above the rest. There may be only seconds to react. That is why rogue waves remain one of the ocean's most feared phenomena. Not because they happen often, but because they happen without much warning. The Pacific is also home to some of the most powerful storms on Earth. In the Western Pacific, tropical cyclones are known as typhoons. They are born over warm ocean water, where heat and moisture rise into the atmosphere. At first, they may be only clusters of thunderstorms. But if the air pressure drops, the winds organize, and the ocean continues feeding the system, a storm can grow into something enormous. From space, a typhoon can look almost perfect. A spinning spiral of clouds, a clear eye at the center, bands of rain stretching for hundreds of miles. But from the surface, it is chaos. Winds roar, rain falls in walls, waves climb, coastlines flood, ships vanish into grey water and white spray. Some Pacific typhoons intensify rapidly. In less than a day, a dangerous storm can become a catastrophic one. Warm water acts like fuel. The larger and warmer the ocean region beneath the storm, the more energy the system can draw. That is why the Pacific, especially in its tropical western regions, can generate storms of extraordinary strength. These storms are natural phenomena, but they are also reminders of how closely the ocean and atmosphere are connected. The sky does not create a typhoon alone. The sea helps build it. Another rare and powerful Pacific phenomenon is El Niño. El Niño is not a single storm. It is a climate pattern. It begins when surface waters in the central and eastern tropical Pacific become warmer than usual. That warming changes the atmosphere above it. Winds weaken or shift, rainfall patterns move, marine ecosystems respond, weather across the globe can change. In some regions, El Niño brings heavy rain and floods. In others, it brings drought. Fisheries can decline when warmer water disrupts the upwelling of cold, nutrient-rich water. Coral reefs can suffer during marine heat waves. Wildfires can become more likely in places where rainfall disappears. The most astonishing thing about El Niño is that it proves the Pacific is not isolated. A shift in ocean temperature thousands of miles away can influence farms, forests, cities, and coastlines around the world. The Pacific is not just scenery, it is part of Earth's climate engine. And when that engine changes rhythm, the whole planet feels it. But the Pacific is not only shaped by water and wind. It is also shaped by fire. Around its edges lies the Ring of Fire, a vast horseshoe-shaped zone of tectonic activity. Here, plates of Earth's crust collide, sink, slide, and break. This is where many of the world's earthquakes and volcanoes occur. Some volcanoes rise above the ocean as islands. Others remain hidden beneath the waves. When undersea volcanoes erupt, they can create strange and dramatic events. Water may bubble, steam may rise, floating pumice may cover the sea, ash may darken the sky, a new island may appear, fragile and smoking, born from the ocean floor. In some cases, these islands last only months or years before waves erode them away. In other cases, they become permanent landforms. The Pacific has created island chains through volcanic activity over millions of years. Hawaii is one of the most famous examples. As the Pacific Plate moves over a volcanic hotspot, new volcanic islands form while older ones slowly erode and sink. This process is slow, but occasionally the ocean reveals it in a sudden, unforgettable way. A volcano erupts, the sea boils, and new land rises from blue water. Another rare event is the tsunami. Few natural phenomena are as terrifying because of how quietly they can begin. A tsunami is usually triggered by an underwater earthquake, landslide, or volcanic eruption that displaces a huge volume of water. In the deep ocean, tsunami waves may not look dramatic. They can pass beneath ships almost unnoticed. But the energy is moving, fast, wide, relentless. As the tsunami approaches shallow coastlines, the wave slows down and grows taller. The sea may pull back from the shore. People may see exposed rocks, fish, or seabed where water should be. Then the ocean returns, not as a normal wave, but as a wall, a surge, a moving mass with the power to destroy everything in its path. The Pacific's tectonic zones make it one of the most tsunami-prone regions on Earth. That is why warning systems, coastal education, and evacuation routes are so important around the Pacific Rim. The tsunami is a reminder that the deepest forces of the Earth can arrive at the surface through water. One earthquake beneath the sea can become a disaster across an ocean basin. There are also phenomena that are less destructive, but equally mysterious. In some Pacific waters, huge rotating currents form visible spirals. Eddies can spin away from major currents and carry heat, nutrients, larvae, and tiny organisms across long distances. Some are small. Some are enormous. From satellites, they can appear like fingerprints on the ocean surface. These swirling systems are important because they move life. A patch of nutrients trapped inside an eddy can feed plankton. Plankton can attract fish. Fish can attract predators. A rotating circle of water can become a temporary floating ecosystem. To the eye, the ocean may look uniform, but to life beneath the surface, currents create borders, highways, traps, and feeding grounds. The Pacific also holds the phenomenon of marine heat waves. These are periods when ocean temperatures become unusually warm for days, weeks, or months. A marine heat wave can bleach coral, force fish to migrate, disrupt seabird feeding, and change entire ecosystems. One of the most famous examples was a large warm water anomaly in the North Pacific, known as the blob. It affected food webs and marine life across a huge region. Unlike storms, marine heat waves can be silent. There is no thunder, no dramatic wave, no glowing water, just warmth. But that warmth can spread through the ecosystem like an invisible pressure. Corals expel the algae that give them colour and energy. Fish move in search of suitable water. Predators follow prey. Species appear in places where they were once rare. A warmer ocean can change the map of life. And in the Pacific, those changes can happen across enormous scales. One of the most beautiful rare phenomena is coral spawning. On certain nights, often after a full moon and under very specific conditions, corals release eggs and sperm into the water at the same time. The reef becomes a living galaxy. Tiny pink, white, and orange bundles drift upward like underwater stars. For a short window, the reef releases the next generation into the current. This mass spawning is one of nature's most synchronized events. It depends on temperature, moonlight, tides, and biological timing. In the Great Barrier Reef and other Pacific coral systems, this event supports the future of reef life. Most of the released material will not survive. Some will be eaten, some will drift into unsuitable water, some will never settle. But a small number may become new coral colonies. A reef may look like stone, but it is alive. And during spawning, it reveals that life in the ocean is not only violent and competitive, it is also timed, delicate, and astonishingly precise. The Pacific's rare events also include animal migrations that seem almost impossible. Humpback whales travel thousands of miles between feeding grounds and breeding grounds. Sea turtles cross entire ocean basins. Guided by sensors, scientists are still working to fully understand. Sharks follow invisible highways through the water. Seabirds travel across open ocean with no landmarks. Salmon return from the sea to the rivers where they were born. These migrations are natural phenomena of movement. They do not appear as suddenly as lightning or storms, but they are rare in their scale and accuracy. A whale that feeds in cold northern water may later sing in tropical lagoons. A turtle that hatched on one beach may return years later to the same coast. The Pacific is not empty space. It is a map written in temperature, magnetism, smell, current, sound, and memory. To human eyes, the open ocean can seem featureless. To migrating animals, it is full of roots. One of the strangest Pacific phenomena is the deep scattering layer. During the day, billions of small fish, squid, and planktonic animals stay in darker, deeper waters. At night, many rise toward the surface to feed. This daily vertical migration is one of the largest animal movements on Earth. It happens every night, almost everywhere, and yet most people never see it. The ocean surface may look peaceful under moonlight, but beneath it, entire communities are rising. Predators follow, prey scatter, light-producing organisms flash. The food web moves upward, then retreats before dawn. It is a hidden rhythm of the Pacific, a nightly pulse, a reminder that the ocean's greatest movements are often invisible from above. There are even places where the Pacific seems to breathe from the seafloor. Hydrothermal vents occur where seawater enters cracks in the ocean crust, becomes heated by magma, and erupts back into the deep sea loaded with minerals. Around these vents, life survives without sunlight. Tube worms, crabs, shrimp, microbes, and strange deep-sea animals gather around chemical energy. For a long time, scientists believed sunlight was the foundation of almost all ecosystems. Then hydrothermal vents changed that view. Here, in total darkness, life finds another way. The water is cold only a short distance away. The pressure is crushing. The darkness is complete. And yet, around the vents, there is movement, competition, growth, and survival. The Pacific seafloor is not dead. It is active, hot, chemical, alive in ways we are still learning to understand. Perhaps what makes the Pacific so powerful is the contrast between its surface and its depths. A beach can be calm while a trench nearby falls into darkness. A reef can glow with color while a storm builds beyond the horizon. A blue horizon can hide volcanic fire below. A silent sea can carry tsunami energy across thousands of miles. A warm patch of water can change weather across continents. A microscopic bloom can affect whales, fish, birds, and humans. The Pacific is a system of connections. Nothing happens alone. Wind shapes water. Water shapes climate. Climate shapes life. Life changes the chemistry of the sea. The seafloor creates islands. Islands shape currents. Currents move nutrients. Nutrients feed plankton. Plankton feed the ocean. And sometimes, when these connections align, a rare natural phenomenon appears. For a moment, the hidden machinery of the planet becomes visible. The wave glows. The sea turns red. The storm forms an eye. The reef releases its future. The volcano rises. The deep ocean lights up. Then the moment passes. The Pacific returns to blue. But it is never the same ocean twice. Every wave carries history. Every current carries energy. Every storm carries heat. Every living thing carries a story of adaptation. The Pacific Ocean is the largest ocean on Earth, but size alone is not what makes it extraordinary. It is extraordinary because it is alive with change. It can be calm and violent, silent and thunderous, beautiful and dangerous, familiar at the shore, unknowable in the deep. And the rare natural phenomena that appear here are not accidents of wonder. They are signs. Signs of a planet still moving, a climate still breathing, a seafloor still changing, a living ocean still creating mysteries. The Pacific does not reveal everything at once. It gives glimpses. A flash of blue light in a breaking wave, a sudden wall of water in the open sea, a reef glowing with new life, a storm spinning across warm water, a newborn island rising from the deep. Each glimpse asks us to look closer, because the more we learn about the Pacific, the more we understand that the ocean is not a background to life on Earth. It is one of the forces that makes life possible. And somewhere beyond the horizon, another rare event is already forming. A current is shifting, a bloom is growing, a storm is gathering, a volcano is building pressure, a whale is beginning its journey. The Pacific is still moving, still changing, still hiding wonders beneath the waves. And the next phenomenon may appear without warning.